Welcome to the DIY Honda Garage channel. The DTC code P0108 refers to a high-voltage condition detected within the manifold absolute pressure (MAP) sensor circuit in Honda CRV models produced between 2011 and 2016. The MAP sensor is a crucial component in your vehicle's engine management system. It measures the pressure within the intake manifold. This measurement is essential for the engine control unit, ECU, to optimize fuel injection and ignition timing, ensuring the engine runs efficiently. The MAP sensor is typically located near the intake manifold, connected to the ECU via a 3-pin connector. A faulty MAP sensor can lead to performance issues, poor fuel economy, or increased emissions. Before beginning any troubleshooting process, it's important to gather existing diagnostic data, including freeze-frame snapshots, to aid in identifying any intermittent issues and to guide the repair process. The MAP sensor plays a vital role in the operation of the vehicle's engine management system. Its primary function is to measure the pressure inside the intake manifold, providing real-time data to the engine control unit, ECU. This information is critical as it allows the ECU to adjust air-fuel ratios and timing, optimizing engine performance. Located near the intake manifold, the MAP sensor is mounted securely to prevent movement or damage from engine vibrations. It connects to the ECU through a 3-pin connector, which carries voltage and signal information. If the MAP sensor detects values above a threshold of approximately 4.49 volts, this signals a problem as noted by DTC P0108 and needs to be addressed without delay. Several possible causes can lead to the triggering of DTC P0108. A faulty MAP sensor is often the primary suspect, as it can provide erroneous readings even under normal operating conditions. Additionally, the issue may stem from loose or corroded connections between the MAP sensor and the engine control unit, ECU, which can disrupt proper signal transmission. Wiring issues such as breaks or shorts within the harness can also cause high voltage readings at the sensor. Hence, a thorough inspection of wiring and connectors is critical in establishing the root cause of the problem. Understanding these potential causes will guide you in performing effective troubleshooting steps. Recognizing the symptoms associated with DTC P0108 can help you address the issue promptly. One of the most immediate indicators is poor engine performance, where the engine may hesitate or stall under acceleration due to incorrect air-fuel mixture adjustments. Additionally, you might notice an increase in fuel consumption as the engine control unit struggles to maintain efficiency with distorted data. The check engine light in your dashboard is likely to illuminate, alerting you to a malfunction within the engine management system related to the MAP sensor. Together, these symptoms not only signify a critical issue, but also emphasize the need for immediate attention to prevent further engine damage. In the first troubleshooting step for DTC P0108, begin by turning the ignition switch to the on position 2. This powers the vehicle's electrical systems without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to check the MAP sensor readings in the data list. Specifically, you are looking for the voltage output from the MAP sensor, which should be more than 4.49 volts under normal conditions. If the conditions are consistent with the threshold, you can move on to the next step. However, if the readings differ, it indicates an intermittent failure, suggesting that there may be poor connections or loose terminals at the MAP sensor or the PCM that need to be addressed first. The second step involves identifying potential failures within the map sensor circuit. First, turn the ignition switch to lock to ensure no electrical current is flowing. After securing the ignition, disconnect the map sensor's 3-pin connector entirely. To isolate the map sensor from the rest of the system, connect terminals A and B on this connector using a jumper wire. Terminal A corresponds to the gray wire, while terminal B corresponds to the green wire. Following this, turn the ignition switch back to the on position 2 and recheck the parameter readings from the HDS. The output should again exceed the 4.49 volts threshold. If the conditions match, it confirms that the issue may lie with the map sensor itself, prompting you to proceed to the next step. For the third troubleshooting step, begin by turning the ignition switch to lock 0. After doing so, remove the jumper wire you previously placed between the map sensor terminals. Next, turn the ignition switch again to on 2 to power the system. At this point, using a multimeter, measure the voltage between test points 1 and 2 on the map sensor connector. These points correspond to the gray and pink wires respectively. Under these conditions, you expect to see a voltage reading of approximately 5 volts. If you confirm this voltage, it indicates that the power supply line, SG1, is intact, allowing you to further diagnose the system. If the voltage isn't around 5 volts, you'd need to investigate the integrity of the wiring further. The fourth step focuses on verifying the continuity of the SG1 wiring. First, turn the ignition switch back to lock 0 to ensure safety in your measurement process. Next, jump the SCS line using the HDS to ensure access to diagnostics. Disconnect the PCM connector C49P to isolate the circuit further. You will then need to check for continuity between test points on the connector. Specifically, you will measure continuity between connector C, pin 24, and the map sensor connector, pin 1. This step is critical as it verifies if the wire connecting the map sensor to the PCM is functioning properly. If continuity exists, the SG1 wire is confirmed operational. If not, repairing any breaks or faults in the wiring may become necessary before proceeding. Step 5 continues the methodical approach to locating faults, this time focusing on the map PB line. As with previous steps, begin by ensuring the ignition switch is turned to lock 0. Jump the SCS line using the HDS diagnostic tool again to access the necessary diagnostic functions. To facilitate testing, disconnect the PCM connector B49P. The goal now is to verify continuity between specific test points on the map sensor connector and the PCM. Measure continuity at pin 31 of connector B and pin 2 of the map sensor connector. If continuity is detected, it suggests the map PB wire is in good condition. Hence, the issue might relate to the PCM software or the PCM itself. In the event of no continuity, repairs on the wire between these points will be essential before continuing. The final repair verification is crucial to confirm that your troubleshooting and repairs were successful. Begin by turning the ignition switch to lock 0 and then carefully reconnect all the previously disconnected connectors, including those for the map sensor and the PCM. After ensuring everything is securely connected, turn the ignition switch back to the on position 2 to power up the vehicle's systems. Utilizing the HDS, reset the PCM to clear any existing diagnostic trouble codes and allow it to relearn its parameters. Despite the resetting process, it's important to check for any active or pending DTCs after performing the reset. This ensures that no further issues are present and that your repairs have addressed the original problem effectively. preventive maintenance plays a vital role in avoiding DTC P0108 and similar issues. First, ensure that the map sensor is checked regularly during scheduled maintenance. Any signs of wear or corrosion on the sensor or its connector should be addressed immediately to avoid future failures. Regular inspections of wiring associated with the map sensor, especially after exposure to harsh conditions, can catch issues before they escalate. Additionally, always verify that the engine control unit (ECU) software is up to date. Honda may release updates to enhance performance or fix known issues. Taking these proactive steps will help maintain the integrity of the map sensor and reduce the likelihood of experiencing DTC P0108 in the future. In conclusion, DTC P0108 signals a significant issue within the map sensor circuit of the Honda CRV models from 2011 to 2016. Understanding the function of the map sensor and the importance of its accurate readings cannot be overstated. Applying the detailed diagnostic steps outlined within this guide is essential for effectively identifying and fixing the root cause of the DTC. Additionally, preventive maintenance strategies will play an important role in avoiding similar issues in the future. By ensuring that map sensors are regularly checked, wiring connections are inspected, and software is updated, vehicle owners can enjoy smoother performance and longer-lasting engine efficiency. Overall, staying informed and proactive is key to effective vehicle maintenance. Please like and subscribe to the channel. See you next time!